Welcome everyone, I'm Jim Corkins and we are now starting your first tutorial for actual instruction in this content area. Now if you haven't watched lecture 1.1, please do so. It really will help you understand electric charges quite a bit. Alright, let's go ahead and start. In these tutorials there are two different types of tasks. One where you're just working with the transfer and charges, just like at the end of 1.1. And the other is about polarization and how polarized objects will draw or push electrons. Right? So let's start with the transfer of charges. Okay. So in these ones, what you're going to do is you're going to draw the extra positive 5 charges. And in this case, positive 5 charges. And then draw your extra 3 electrons over here. Okay. Now, draw a couple extra neutral charges to work with. Okay, so I'm just going to draw like an extra 2 neutral objects. And you could draw some extra ones if you need it. But I'm going to make them neutral. That way you have something to work with. Okay. Right. So on this guy right here, you know what? I'm going to draw a couple extra here. They don't have to be even. So I'm going to draw a negative there and negative there. And I'm going to draw 2 other neutral on this, just to be sure. I'm not sure how much I'm going to need in this, but I just want to make sure I have it. Now, I'm going to take those and I'm going to bring them to the other 2 objects right here, like so. Hopefully you're working with an iPad or something or a tablet. It'll make it easier for you. Okay, now what I'm also going to do is note that I have a positive 5 over here and a negative 3 here. Now when you connect them up with a wire, the first thing that's going to happen is these negative 3 charges are going to move to the other side. They're going to immediately move over here and begin attaching themselves. So I'm going to draw a negative here, a negative there, and this guy's going to get a negative as well. And so when we do that, we're going to have a positive 2 and we're going to have a 0. Now the problem is, now I have a positive 2 and I have a 0. And I'm going to just make sure I carry these over here and negative here. So I have a positive 2 and 0 here now. Okay. Now I need to make sure, since they're connected, that, and there's no polarizing object, that they have an even amount of charge, right? So I have 2 objects and I have a positive 2. So what I need to do is make sure they're both positive 1. So what we're going to see here is that one of these negatives, and I'm just going to grab this guy right here, is going to jump over onto the other side. And when we do that, what we're going to have left over is a positive 1 and a positive 1. See this object? That's the positive on this side, and here's the positive on this side. Okay? There's a lot of ways you could do this, but you need to work this out so that each object is equal in the amount of charges. Okay? And we're not dealing with nanocoulombs or anything like that, like the end of 1.1 tutorial. So we're dealing with whole charges. So you can't have like a fraction of a charge, right? So this is the transfer of charges. Let's try the polarization one, okay? Now this one may seem to be confusing at first for some people, but it's actually quite easy. You just have to stick to the rule that only electrons can move. I wanted to add an extra one so we have better context on some things. So let's go ahead and get started. Here we go. This is the polarized object. Now, the rules for this, which is similar to the other one, again, only electrons move, but in this case, the polarized object is going to change what kind of happens here. So in the last one, when you just had these two objects, they would equalize the amount of charges on one object and on the other by exchanging electrons. But with this polarized object, that's going to kind of change some things. So let's go ahead and talk about it right here. So this guy is positive 5. And so that's not going to change. This positive object is not touching the other objects, so it will always be positive 5 across all of these. Okay, this is positive 1, and I'm going to draw that down on through each of these. And then we have our negatives here. 1, 2, 3. 1, 2, 3. So this will, these guys, this will be positive 5, this is positive 5, and this is positive 5. Right now, that one's positive 1, that one's negative 3. But when we connect the line up, we're going to start right here. Okay, now here's how I see this, and this helps me understand how polarized objects draw other charges. So this positive 5 is dictating that in order to balance it out, a positive is going to try, this positive 5 is going to try to pull over negative 5 into here. Now this already has an infinite number of neutrals, so there's a bunch of pluses and minuses, and I'm sure the minuses are kind of aligned here. We just don't see them. But this object is positive. It needs to pull over 5 electrons from somewhere, and it can't pull it over from this object. The only object it could pull over those 5 electrons is over here. So it needs to pull over 5 electrons from this object here, from this other object, since this is positive. If this already had like a negative 2 on it, it would only need to pull over negative 3. Okay? And we can look at that in a second. But let's talk about this right now. Okay? So right now, it's got to pull over negative 5 from this object. Okay? But this object already has negative 3 on it. So it's got to pull over an extra negative 2. It's going to pull over those first negative 3s, and then it's going to pull over an extra negative 2. Okay, so starting out, let's equal this out, or do our best. These 3 electrons are going to jump over. One of them is going to attach to this guy, and the other 2 are probably going to go right here. Okay, so now when we do the mathematics here, and I'm going to bring these 2 guys here. So now when you pull those 2 over, or those 3 over, what we're going to have now is a negative 2 object, because one of them got nilled out, and a 0. So right now we're at negative 2 and 0. Well, what we don't see is that there are billions of neutral atoms over here, billions. Okay, but we only need 2, so I'm going to bring those 2 to light. Okay, so now we see, since we pulled negative 3 over and we need 2 more electrons, it's got to come from 2 neutral atoms. And so these guys are going to lose those 2 electrons, and those 2 electrons are going to travel over to here. And now what we're going to have is a negative 4 and a positive 2. So negative 4 and a positive 2. Okay? So again, this positive 5 is pulling over electrons. And right here, if we connected this with a wire, it can't pull over anything from this guy. This guy is basically positive 1 and always will be positive 1. So it has to pull those 5 electrons over from the other object in this case. Okay? I want to show you the antithesis of this. So in this case, there's a -5 right here, 2, 3, 4, 5, and then you have a -1 over here because they're going to be repelling each other from that guy. 1, 2, 3, 4, 5, and -1, 1, 2, 3, 4, 5. Okay, now you have a +3 over here. Okay, so +3. Let's make this negative a little bit more prominent right there. So now what we have is -5, which won't change because that sphere is not touching the other ones. But we're starting off right here with -3 and -1 and +3. So this object again is dictating what to do with these two guys. So these -5s want to have this guy, wants to bring over 5 protons, but it can't because protons don't move. So what it has to do is push away 5 electrons from this object. And it already has 1 electron right here. Right over here, these electrons over on this, which are a bunch of neutrals, those neutral atoms with their electrons are probably lined up over here, right? But it can't change anything. The only way this can push away 5 electrons is from this object, okay? So what we're going to do is start off by pushing over this first electron, and it's likely going to bind to the first atom it sees. So now we're going to have 0 and +2. 0 and +2. So now that's where we're at. 2, 3, and right here. So right now, this last one is 0 and +2. Now we pushed over 1 electron. There are 4 more electrons that need to get pushed over to this object. So that means we're going to need to pull them and bring to light 4 neutral atoms. Okay, they were already there. We're just kind of making them known now because we need them. So now we have those 4 electrons, right? We push over 1, there's 4 more electrons. So I'm going to take those 4 electrons, and as I'm deleting them, this object is becoming more positive. So I'm pulling from 4 from that neutral, and now those electrons, which are going to move over to here, so 1, 2, 3, 4 are going to probably move over here, be kind of attracted to here, maybe repelled, I'm not sure. Either way, this has 5 electrons that got pushed over. So now this object is +4, and this is going to be -2. Okay? So that's the deal. This guy was dictating, so this is -5. It wanted to push over 5 negatives onto this other object. Okay? If it's +5, it's going to pull electrons over to the middle object from the other object, likely. Okay? I did mention a case where, what if this is +5, this is, let's say this is already -2, and this is -3, right? Well, that's 2 on the money. So let's call this guy 0. Why not? Okay. So here we got our circles, our spheres. We're going to connect this up. If this is +5, 1, 2, 3, 4, 5, and this is -2. Well, these two negatives are already going to go here. So it's got two negatives that are basically trying to connect to there. The only thing left to pull these two negatives is pulled it over there. It's got to pull 3 more from this other object, right? So that means you have to make 3 neutrals become come into being, right? Or just reveal them, right? So here's the case, nothing has changed. So what we're going to have to do is pull 3 electrons over. And now, when we do that, those 3 electrons are going to align 1, 2, 3. And what we will have for this case is -5 plus 2. Plus 3 in the end. Okay. It started out, oh, I don't know why it zoomed out there. Duplicate that. It started out originally just to, again, to remind us all where it was in the beginning. It started out -2 and 0. But 3 electrons, because I already had -2 there, had to get pulled from the other object. Okay? So hopefully this helps you out with polarization. Look, the main idea here is that electrons move, protons remain where they are. Okay? And if you have 2 charged objects and you touch them together and they're metal and or a wire's connected in between them, they're going to share charges, share electrons until they are equal in overall charge, right? The net charge on both objects will be equal. With polarized objects, if you have a polarized object here, it's going to try to do whatever it can to pull over an equal number of negatives onto that other side. And if it starts out with some negatives, it's only going to pull 3 more onto that side, right? Such that in between these 2 areas is 0, right? It's trying to connect it together, right? This guy wants to touch this so that it overall, both of these will be neutral, okay? That's kind of what's happening. All right, have a great day.